Hi guys, I'm the blockchainer or broker, and we are going to do a shadow audit. In this case, I chose the Asymmetry one, Asymmetry Protocol from Code4rena. So what we're going to do is to check the scope of this audit, because the protocol is bigger. So we'll see which smart contracts are in scope. We'll take a look to the documentation, the website, and we'll try to find out more about what is the protocol about and which are its main features. And then we will jump to the code overview, or what is commonly known as the first step of the audit for many auditors. Basically, we're going to get familiar with it. We're going to try to raise or find those more visible bugs, or at least we'll add any notes when we notice anything more important. And that way, later we will go back, not in this case, but usually when you do a full audit, you would just go back to those points and continue analyzing them. So what we will do instead is after this code overview, we want to go to the Code4rena's report that it was raised with the whole issues. And you know what? There are more than 8 high risk severities raised, 12 medium severity issues, and 30 low severity issues raised. So you will be surprised also how many line of codes are actually on scope. So let me show you. First of all, I want to show you what is in scope. So in scope, guys, we have 4 smart contracts, total of 460 lines of code. And if you heard, as I mentioned, there are a ton of bugs raised, a ton of issues. 8 high risk findings. So whenever you're told that in a small project is very unlikely to have a lot of issues, then as you can see, this is a proof it's not. This was a big thing. So we will be analyzing those later on. But for now, let's find out more about the protocol through a bit of their documentation. So here in the repository, they added some short description that I want to go through. And but before maybe starting to get familiar with what is this. So we have this safe ETH as the main contract, and then we have this WST, SFRX ETH, and RETH. We will find out later. I will tell you how you should also find out more about those namings, so you know more about the protocols. So so that you know now when we go through the overview, that is not the first time you use it. So Safe ETH is a smart contract developed by Asymmetry Finance that enables a user to diversify their ETH into stake derivatives. Currently, the supported stake derivatives are those that I've mentioned. The goal of Safe ETH is to help decentralize the liquid stake derivatives on the Ethereum blockchain. This is done by enabling an easy access to diversification of derivatives. In the future, Safe ETH will be used in conjunction with other smart contracts to allow the staking of Safe ETH to gain higher yield. And here is a very nice diagram provided where it shows the main features, the main options, which is stake and unstake, and that are in Safe ETH contract. So when you send ETH, you mint Safe ETH, and when you unstake, you receive ETH. And those derivative contracts mentioned. So about the two main functions, stake and unstake. Stake is the main entry point to the protocol, as we've seen. We'll take the user's ETH and convert it to various derivatives based on their weight and mint an amount of Safe ETH that represents a percentage of the total assets in the system. And unstake, that's the main exit point from the protocol. We'll burn the user's Safe ETH and convert a percentage of each derivative to give the user their ETH back, including any of the rewards their derivatives have accrued over time since they started staking. The protocol contract is Safe ETH and the derivative are those. So Safe ETH is an upgradable ERC20 contract that handles the conversion between ETH and whatever derivatives that are implemented. And these contracts handle all business logic to deposit and withdraw. That's probably going to be two of the main functions through their specific protocols. Okay, so let's see also, I wanted to show you guys a bit more of context of asymmetry. And Asymmetry Protocol has been developed as a comprehensive solution to address the issue of centralization within the staked Ether market. Maybe you are not, or maybe you are aware of what's the staked Ether market, but maybe you have heard of Lido Finance. So mainly, in this protocol, the users will be incentivized with an efficient yield generation model, resulting in market-leading returns. So in general, there is a current dominance of Lido Finance, which is controlling up to 88% of the staked Ether market, which presents risks associated with centralization. If one protocol is taking 88%, then yeah, it's fair to say that. And yeah, this concentration of control poses vulnerabilities in the event of bugs, severe debugging, or regulatory sanctions. I want to show you a bit more about this in the decentralization Ethereum part. In this section, we can see the graphic where we can we can visually see the dominance that is mentioned above. And yeah, the goal, as I understand from Asymmetry, is to give another option. It's like it's another option for the user in general. And I don't want to go much more into details here. I didn't find that it's super necessary to go through them, but who knows? Maybe we'll come back. About the staking, well, it's minting safe ETH, which requires users to bring ETH, and unstaking, which is burning the safe ETH, and it gives back the ETH to the user. And yeah, for now we will leave it there. And I want to show you the website. Like in the previous shadow audit, I mentioned that it's important to just Google or search for the main site so that it can give us some feeling about what is it that it's doing, or it will also give us some more information. So let's see here. It mentions about about decentralizing Ethereum with SafeETH, right? That it's as an alternative to Lido Finance. And yeah, let's see. When you deposit into Asymmetry, you're getting a piece of many staked Ethereum derivatives. So you give ETH, but you don't only get safe ETH. Actually, it's split in those tokens, and we can see now what it stands for. The WST is Lido Liquid Staked Ethereum, R is Rocket Pool Liquid Staked Ethereum, and SFRX is Frax Liquid Staked Ethereum. And this is about, I mentioned again, the increasing the goal, one of the goals, increasing decentralization. And wanted to mention also, saw it somewhere, that Asymmetry is a DAO governed by the ASF token, and 100% of protocol revenue goes back to users and the ecosystem. And with that said, I think it's time to jump to the code, guys. So as I mentioned before, this is so we're going to take a look at the Asymmetry code, and this is a protocol that I have reviewed in the past because it was the first audit I performed in my first month studying Web3 security. So I left the notes that I took then, and we will be going through them. We will be checking and discussing if it's valid or not, and why I raised it and how I wrote it. So let's start, guys. First, in the contracts, we have the contracts on scope, mainly in here, the safe ETH and the derivatives. So let's start with safe ETH, which is the main one. And the first thing I catch is that we are seeing here the floating pragma. This is something we want to avoid, and ideally you would use it like that. So that's a valid thing to report. I didn't add it back then. I guess I didn't know, but probably I didn't know. And we can see how it's importing the ERC20 and subrouter on about upgradable and ERC20 upgradable, and it's extending them. Here it's also important to mention about the node spec that it's added for the contract. That's good. It's valid thing to verify in general for contracts and functions overall. So yeah, here it says that in this contract is the contract that means and burns and provides other functions for safe ETH, and the author Asymmetry Finance. So the first thing that we see here are the events. It's important to remember that there is a structure to follow. So in this case, it's good that the events are declared on top. Sometimes I've seen them declared in a different file and just imported here and just use whenever it's emitted. But yeah, it's good. We can see they are some of them indexed. But yeah, okay, let's see. The first thing that we notice, the constructor. It says disable initializer. So this is the cause, guys, because it's an upgradable contract. So an upgradable contract that uses Open Zeppelin, it's disabling the constructor and using instead the initialize functions. And here it's acting as the constructor. We can see that it's passing the token name and the symbol because it's an ERC20 after all. And yeah, this is also we can see that they provided some documentation. That's very good as well. And we have the NAT spec specified, so the information. Okay, let's see what's inside. It's using the ERC20 init from upgradable. It's like if it wouldn't be upgradable, we would see here that the ERC20 and for the in their constructor to initialize the name and so on. But since it's initialized through the initialize, that's why it's done in this way. And here we can see a red tag, and I marked back then that it's safe transfer ownership to be used better than this. We'll see that later if it was an actual issue raised. But yeah, I marked that back then. I guess I did some research trying to figure out if that's the proper thing to use and so on. But yeah, we'll find out later. So in general, what it's doing is that whoever is deploying it, that would be the message sender, and that would be then the ownership will be transferred to that account, and that will be used for those functions marked as only owner. Okay, so next actually we can see another tag, which is avoid magic numbers. And as we can see here, this is the reason, because it's just showing here that minimum amount is 5 times that and 200, but it would be better to have it declared as a private constant and called mean amount or max amount. That's something worth mentioning from time to time. It's something I've raised. Even in other programming languages, it's better to avoid magic numbers and always use constants if possible. Yeah. So function stake. So this is one of the main features, right? So this to stake your ETH into safe ETH. It deposits into each derivative based on its weight and mints safe ETH in a redeemable value which equals to the correct percentage of the total stake value. What we notice first is that it's payable, so we would expect some value being sent when called, and it's external, so anyone and everyone can call it. There is no role restriction or anything like that, so it's for every user to use. The only time when they will not be being able to use it is when it's marked as post staking. So whenever this is true, it will not be possible to stake. Now here we can see a first issue. Actually, it's nothing big, but it is worth mentioning that it's not good practice to add equal false when you are in a condition, a require or if or any other type of condition. It is enough in this case to leave it as with the exclamation mark, and this would be the same. Yeah, and as it's not necessary. Also, we can see the other requires, which is checking that provided value is bigger than the minimum and smaller than the maximum amount. And another thing raised here, it's apparently then I marked it as doubt, but now I can confirm that you don't need to assign it to 0 in these cases for unit 256 or any unit because the default value is 0, and you don't need to specify that default. I think it also takes some extra gas, so it's unnecessary. The same in the for loops. If you see that, it's worth reporting. Okay, so here it goes for every derivative that we have. So for any of those tokens that exist or that we have added, and it takes it is increasing the underlying value by this operation mainly, taking the balance from ETH per derivative and from derivatives in general, and that's its use later, as we can see, to calculate the pre-deposit price. Now, another thing I raised then, and it's worth mentioning, is that is using a similar name from an inherited variable. It's called shadow. It's called this variable is shadowing something inherited. In this case, the ERC20 upgradable has total supply. So I did trace that, and I can tell you it's also valid. Continuing, we have the condition to verify to make sure that total supply here it's not divided by 0. We are adding a condition, and if it's 0, just it would mark it as or initialize with a price of 1. And if it's not 0, then we're safe to do this operation. I want to remind you guys that in this case I'm not going into many details because we're doing a kind of overview of the code to get familiar with what it's here, how it's what it's been done, and so on. And in this case, after we do this overview, we're just going to go through the report, and we would then maybe get a bit deeper because we'll see where the issues are. But we will be more familiar doing this overview than if we would just go directly to the report. So continue with it. We're raising again that no need to initialize to 0, and what else? It continues with some checks that if the weight is 0, then just exit. No need to continue with it. Using continue is a way of exiting that condition apparently. And something I noticed then is that there is no check because there's some chance that this could be 0. I mean, if this dividend is 0, then the transaction actually reverts. So that's why I pointed it out, and I'm not sure, but I will check later. But I think it should be valid point, at least to add a validation there to avoid this. And deposit amount. We're sending this ETH amount. Okay, and doing some extra calculation. I can see here that it's using int and not explicitly int 256, so that's actually another thing to worth noting, worth reporting. And okay, I think I've raised this somewhere else, but this ideally we can propose here a way of saving gas. So I would add just here that with the tag, and I would say maybe you have guys seen it before, but it's cheaper to add it in this way. So instead of adding it, increasing the amount by using the plus equal and we want to increase it the amount of y, it's good thing to, as a feedback to gas optimization, to declare it like that. So, okay. And okay, I can see that we are minting as mentioned above. So on stake, we are minting save ETH here to the message sender. The mint amount, which is calculated here. Nice. Let's move on, and time for unstake. Unstake your safe ETH into ETH. Adding unstakes a percentage of safe ETH based on its total value. And the parameter safe ETH amount is the amount of safe ETH to unstake into ETH. Again, I noticed the same thing. This could be done differently, like that, like here. And let's see, we're taking the total supply, we're getting the ETH amount before and probably ETH amount after. And in the middle, we're doing some operations. For each of the derivatives, we're calculating the amount and ignoring if the derivative is empty. Okay, so that's what it means. With that, continue. And then we are burning to the safe ETH amount that it's been requested here on top. I'm wondering now, this amount, if there is any check. There is nothing checking if this amount is 0. And if it is 0, this derivative amount will be 0. Okay, so it's handling it in this way. Okay, I think it's good enough probably, as long as it's our area. because there is no requirement here on top checking that, because here the user or the hacker, whoever who could just specify whatever they would want. So it's worth also making sure that there is some kind of validation on the UIN 256, at least to not be zero, or depending on the feature, then any type of verification. But yeah, it's burned, and then that amount is sent to the message sender. I did mark that here as redundant to add the address as message sender. I'm not 100% sure that was valid. I think it is, but yeah. Something I can notice now is that it's using call to send the ETH and then checking the require. I would say that it's safer to use transfer, actually, and then checking also the return, because transfer also gets a boolean back. So actually this is something worth reporting. Like at this stage, I would not just get deep into that, but I can see, or I know from the past that it could be raised. So I could mark for now use transfer instead. I would leave it here, and then I would just come back and double check and make sure it's or what's the impact also. But yeah, so that's so far. Now let's go further. We have rebalance to weights and not just weight and not derivative functions. So the main function we already went through it. So let's see what else is handled in this smart contract. Here we have these functions which are actually only owner. We can see it's only owner, and only owner. And that, guys, takes me to another potential. Actually, it's been proved that it's a valid thing to raise, and that is that it is by having only one owner and not different roles, it's a point of failure, it's called. So if the keys are stolen, lost, or whatever, then these only owner functions would not be reachable anymore. And yeah, this is actually a worth pointing, a issue worth raising, and it is I can mark it here as only owner as main point of failure. And yeah, then I would come back later to it and verify it. But let's see what it's doing. You can see checking the balance before, probably checking it after, getting the rebalance, making some calculation with it, and then checking which is the ETH amount that needs to be deposited. The price will change due to slippage, it says. Yeah, that makes sense. Okay, it will be deposited on the specific derivatives. Okay, to each of those, yeah, that's why it's using the I. Alright, so next, adjust weight, it adds new derivative to the index fund, and it passes the parameters index of the derivative you want to update, the weight, and the weight itself, the amount. It's also here not checked, actually, the amounts passed, here there was not, but here we're not double checking what amount we are passing, so that means that maybe it's fine if what happens if the user adds here 0. Okay, actually it's only raised by the owner, but still it should be doing some checks, and maybe it's not necessarily to go through the whole function logic if the weight is 0, for instance, or derivative index. Maybe okay, this actually can be 0 because it's an index, but the weight might be worth adding some notes there. But yeah, I don't see any. In this case, there is no operation with it, so yeah, it's not too unsafe. But yeah, keep that in mind. And here in this function, we add the new derivative to the index fund. Okay, we're passing the address and the weight. Okay, and guys, here it's an important point raised. I noticed that there is no verification that it's not past the address 0, and this is important. So yeah, let's go on. Yeah, we can see here, as we've seen before, the derivative count in the loops used, in the for loops. We can see that it's because every time we add a derivative, we are increasing that count. So that's why how we keep trace of how many derivatives are existing. What else is done here is, okay, notice again default value declared. Okay, now moving forward, we have this set maximum slippage function, which is also only for the owner. And okay, something I noticed here earlier is the uint. It's not saying uint 256. So that's worth mentioning, those inconsistencies. And yeah, we're setting the maximum slippage. Then here we have set max amount and minimum amount of the minimum stake value and maximum stake value. Adding some requirements, some conditions that that amount should be smaller than the maximum amount, and yeah, and that maximum amount should be bigger than the minimum amount. That's the very good check, yeah, for sure. And the set post staking, if you remember, we've seen this, that it's blocking if it's able to block the staking or the unstaking. If this is false, as we saw on the top, one of the first, if not the first, yeah, verification was to check that it's not set as true. It's required to be false. And that's handled with these functions. Okay, so that's all for Safe ETH, the contract. So we already took a look at it and we know that it's the place where it's staking and staking and handling some of the derivatives. Alright, so let's continue with our ETH.solve file. Okay, let's check this smart contract. We can see what we mentioned earlier, the pragma, floating pragma, two raise as well. So when you specify that the issue is like just one issue and then raising the different instances that are in the project. And yeah, we can see it's importing some interfaces. Let's see later what it's being used from them. The iSwap router, so potentially we'll be doing the swap. It's also upgradable. Okay, Uniswap v3 factory. That's interesting. Okay, nice. All right, let's see. It says that this contract it's a derivative contract for our ETH. Okay, I'm mentioning here about this honorable two-step upgradable, but now I'm just not too convinced that was actually a thing. So let's leave it for now. Okay, here is declaring the addresses. Rocket Storage, WETH, Uniswap router, and Uniswap v3 factory. I did read somewhere, and that's why I added this part, that it's not recommended to hardcode the addresses, because if there is any update in the future in those smart contracts, then you can't modify it. So I'm not sure if the right way is having a function that actually sets that, or if the contract is upgradable, then you can be setting up those addresses in the constructor or in the initialize in this case. So I think it might be a fair thing to raise. If you guys have any different experience with this, please let us know. Like, you can write it in the comment. Of course, it will not only help me, but any other person that will be interested on this thing. So, okay, let's continue. We're defining here a public maximum slippage value, constant like variable. And of course, we're disabling the initializers as we've seen before. And we have the initialize, mark the same thing as I mentioned, which I'm not sure if it's actually an issue. But yeah, we will find out later. And defining the maximum slippage, again, I think this would be a same thing to mention as a magic number. So it would be beneficial to move it to a constant. Didn't raise it here, but yeah, since it's set to a 1%. Okay, so let's see what else it's doing here. I have the function name, which is only returning a string set as memory. So here I mentioned that this could be a constant instead of a function with hard-coded return. And the truth is that I didn't update this node, but I remember checking that on Remix. And as a matter of fact, it is cheaper to have in such a function. I'm not often seeing this approach. Not sure why it was taken like here, but yeah, actually I wanted to suggest it as a gas optimization, but I did check, and yet it isn't. But yeah, it's definitely getting the the name of this contract. Let's move on. So we're setting the max slippage, and again, it's only owner. And also, we're not verifying the amount. We're not checking if the max slippage is bigger than the previous, for instance. Actually, that's something I would add. Like, no, like is slippage bigger always, let's say. And then I would just double check later, or that's what I would do. But in this case, we can leave the note and check later on the report, and we can come back to it. But yeah, it's interesting to know that in general we always want to check all the parameters. So yeah, because anyone can, okay, not anyone, it's external, but only the owner. But still, if it would be stolen, then yeah, it would be able to set anything and set the max slippage to 0. So that's the problem here. But if you have a validation that reverts if it's set to 0 or very low, for instance, then you're covered in that case. Okay, next we have basically another new function, so it's like a getter, which is returning the reth address, as I can see. It's getting it with a encode packed. Okay, I guess not much to see there, probably. Yeah. Let's go on. Okay, we have the function swap exact inputs single hop. So it swap tokens through Uniswap. That's why we're importing Uniswap. And it has a few parameters, and it's well specified within that spec tags. Token to swap from, token to swap to, pool fee for the swap, amount of tokens to swap from, and the minimum amount of token to receive the slippage. So that's not to leave the amount out minimum input as 0, because that's dangerous, as it can be front run or. Okay, so what are we doing here? First of all, it's approving Uniswap router address, right? Yeah, spender. Yes, it's approving the Uniswap to spend the amount specified of this token, the provided. Okay. And then we're setting the exact input single parameters, so that's part of the ISWAP router from Uniswap. Okay, basically passing the parameters that we pass to the function. And this function actually I wanted to check is private and returns amount out, which is returned from here. Good to know. Let's go on withdraw. Okay, so we have swap, we have withdraw. We're passing, it says convert derivative into ETH. Right, it's taking out, withdrawing everything, anything that is inside, you specify the amount. Actually, it's only by the owner. And then we're sending to the message sender with call the balance of this reth contract. Okay, that amount, yeah, no. That amount, it's burned. Okay, I guess it's interesting. Withdraw, but we're not specifying this. I'm not seeing any similar. Like, how do we know here that is the right or the expected amount? I'm not sure. I did mark here that, but I think I was just based on. I saw somewhere that call can have such issue. Again, I think what I've seen before, transfer use instead of call, it could be a solution, but maybe in some places it's fine anyways. But yeah, it could be changed and use transfer instead. As I remember, it's supposed to be safer. But yeah, here I'm not sure why there is no kind of correlation of the amount that you're burning and the balance of this. That would be something that I would check, but let's move on. We have the pool can deposit, so it checks whether or not our ETH deposit pool has room users amount. So we're passing the amount. These are private, so it's like a view and private, so it's like a getter to be used internally. And we have the address of Rocket deposit pool. Let's see what else. Rocket protocol setting address, defining a few addresses here. And we're returning, yeah, it's a boolean, so it's basically if the balance of Rocket deposit pool plus the amount provided is less than the maximum deposit pool size. Wait, yes. And okay, that's one condition. And the next one is to be, and the amount is at the same time higher than the minimum deposit. Then it returns true or false. Pool can deposit. Okay. We will see maybe later what it's used. And deposit. Actually, guys, if you remember, we've used that, or we've seen that in this contract. Oh, here actually. So yeah, that's the deposit that it deposit into derivative and will either get our ETH on exchange or deposit into contract depending on availability. And here I noticed that it's not using the name return variable. Why? Because you were saying you were returning you into 56, and we actually had to define it, as I can see, not use anywhere else. So this would, if this could be gone, and then that would be added here, and you save some gas actually. And considering that this is a probably very used function, then it makes sense. You can always specify that if it's potentially used many times. That's it. The Rocket Bulldogs query addresses each time it is used. We get the deposit pool address, and we're checking the value that it's. Okay. Okay, this is the function, so we will check if it's false, then it will enter, and it will do some checks. Full price. Not sure where it was coming from, but when I see always something being divided like this in the dividend, then I always want to check the possibilities for it to be zero, because it's important to be covered. And anyways, he's doing some other calculations here. These things are often based on the invariants or the specific features or some expected fees or things like that. That's why these things actually it's worth when auditing more deeply. It's just about having the docs on one side or what it's expected, and then reviewing that all this part it would work correctly. Okay, we're here using deposit as well from WETH actually. What else? Okay, we are using swap exact input single hop here as well, getting the amount swapped. Apparently it returns that. And I'm reporting again here a magic number. Then if it's here, it will return the amount swap, but if it can't deposit, apparently, or if it can deposit, yeah, then we will enter the else and do some, okay, we will send the value deposited to that contract and some other verifications. Okay, this is basically protecting from the underflow. Yeah, I mean it's covering other things, but yeah, in general that's what it's doing. And let's see further. We have ETH per derivative, so we get the price of derivative in terms of ETH. We need to pass amount so that it gets price from the same source that it buys of mints the R ETH, and it passes an amount to check the ETH price. It's public and view, so like a getter again. And I'm wondering if, okay, no, here it's okay to not pass the name return. Okay, this function is just with this condition. And something that I noticed, I think, is that by multiplying pool price for 10 elevated to 18 and divided, this like they cancel each other. So I thought to report that because it could, well, it's less operations, so it should be cheaper. Actually, because this has no sense. When you multiply per 2 and divide with 2, then you get the same number, right? So I understand it would be the same situation here. Anyways, the zeros would cancel each other. Balance function view returns the balance of our address and the pool price. Another getter, private price of derivative in liquidity pool. We're passing? No, we're not passing any parameter. You will get from Uniswap v3 another magic number. Okay, and it's getting it from the storage. It's storing this part, and that's what is being returned. with an operation. Okay. Yeah, interesting. Also, I noticed this. I'm wondering why would you multiply it like this? Or either you use some constants to be explicit to what is happening, or just add the result, and you have less operations to be done there. Okay, we have array done. So overall here we are, yeah, we have the deposit and quite a few, a deposit and withdraw, and some swap function, but that's being done internally. Let's move on then, guys. Next contract, there is FRX ETH. I guess all of them have the pragma, floating pragma, so that's about defining, like reporting all of them. Whereas I'm wondering if this is going to be very different or quite similar to the other, but seems more or less the same. Defining the addresses, public, constant, yeah, max slippage, the constructor as we've seen before. Initialize the same, yeah, the return the name in the string. Setting the max slippage, so we've gone through all this, that's why I'm just moving forward. There is the withdraw. This withdraw is using redeem from is FRX. Okay, that wasn't in the other one. The withdraw is only owner as well. And redeem amount address this, and let's see what is this. It's the first is the shares, then the receiver and the owner. So the receiver is the owner. No, wait. Well, yes, this contract is the receiver and the owner of the of what? I'm not sure now. Address owner. Can I go inside? Yeah, there is an interface probably, yeah. But yeah, anyways, I guess it's the same as the only owner, and since it's withdrawing it, so that might be the reason that's why it's the owner. We're saving the balance, which we're using to approve this address to use it. Let's see what is here. We are passing amount to ETH per derivative, but inside it the value is never used. Amount. Okay. Yeah, I think I remember that. We have it here. And also the ID is pointing out that unused function parameter. So in this case, if I'm not mistaken, we can do something like this. Don't get scared, it's okay. Like that, yeah. So that way you avoid that warning, or you would just remove it. However, sometimes if it's overridden but not used, then you can't remove it if you need to override it. But yeah, let's go back up. Yeah, the thing is that it could be an issue, right? Because maybe it would be expected but not used, so that's what I was concerned. We'll see later if that was raised or valid. And from that anyways, we're getting the minimum amount, which we are passing here to exchange the minimum dy. Not sure actually what is that, to be fair, but yeah, again, more magic numbers would be good to know what is that as well, but yeah. And we're sending the balance to the owner, okay. Then we have deposit, external payable, and only owner. Guys, it's always good practice to make sure it's external if it's expected, and if it's external, check if it has any restrictions. So yeah, it's always making sure, because it's considering that we've seen this in other contracts. If by any chance suddenly we would see that it has not only owner modifier, then it would be a flag there that it's been missed. That's why I always repeated that. We submit and deposit the value sent to this function, and we store then it's sent to this contract, and then we are storing it and subtracting the previous balance, and that will be the amount deposited. Okay. ETH per derivative, okay, we already went through that, and the balance of this contract is returned, and we have a receive external payable. Okay, very similar to the previous one. We're withdrawing, depositing, setting maximum slippage. Those are the main things. Let's go to the last, guys. Last contract. So the floating to be reported. We have the addresses, as I mentioned earlier. I would investigate that more if actually it's convenient to have them as constants here, or if it would rather be, or if it would be better to be specified in the initializer. I'm under the impression that it could be safer if it's well, in general, but if it's upgradable and the others would change if we would have declared it in the initialize, we would be able to update it. Not in this case, however. But yeah. I might be wrong, so please, if I say something that doesn't make sense, I am more than happy to hear the right reasons for this. So again, if there is to me privately or add a comment. I need to learn anyways a lot, so might be saying something not correct. Okay, initialize, same as before. Name Lido as the name of the derivative. Okay, setting max slippage and the withdraw. Apparently, each withdraw has different logic. I'm wondering why. It's an interesting point. Definitely and obviously, that would require a big more effort on understanding what's the reason why it's different deposit and different withdraw. Why is the reason for that? But yeah, so far we can see that it's using an unwrap from that interface. It's returning a uint, which we're actually not storing anywhere. I'm wondering if it shouldn't. What are we returning? Well, in this case, is where named return value it's helpful because then you know something more than just amount. But yeah, it's something I would double check as well to make sure that was not expected or needed or useful, that return value. Going further, we are approving Lido CRV pool to spend this token, this amount, actually. We're defining a minimum amount, considering the slippage, the maximum slippage, and we're doing the exchange. I think exchange we've seen it in the previous contract as well. And also it's specifying 1 and 0 for the first, the second and third, the first and second parameter, yeah. Whereas when we're sending the value with call, then we have deposit. It's the same as before, actually. Returning this amount. Again, it could be name return value. And we've seen that before. And the balance. Okay, guys, so we have seen the 3 different derivative contracts and the main one. So that's all for this overview of asymmetry. We have now here the asymmetry contest findings and analysis report. And considering that this was a audit, the scope of this audit were 4 smart contracts, I have to say that 8 high-risk findings are quite a lot, and it's going to be very interesting to understand what's happening, and that way it would be a nice learning for us to know that even if there is not many lines of code, it doesn't mean that there are little issues. So let's start from the high-risk findings that we have here, and let's move on to try to understand them, and we will be going back to the code to double check where it's been and if we have noticed anything earlier. So let's start with the first high. It says an attacker can manipulate the pre-deposit price to steal from other users. Okay, I want to check now in the code where is that pre-deposit in safe ETH apparently. We've seen that before, price of safe ETH in regards of ETH. So we have it here. Let's see. Let's read more about it. Actually, it's mentioned exact place. Line 79 and 98. So 79. Okay, that's not exactly because I have some notes, but yeah. The impact. The first user that stakes can manipulate the total supply of SV tokens and by doing so create a rounding error for a subsequent user. In the worst case, an attacker can steal all the funds of the next user. The proof of concept says that when the first user enters, the total supply is set to one elevated to 18 on line 79. Okay, that's happening here. But the user can immediately unstake most of his safe ETH, such that total supply. I'm not sure what they mean. It's much less than that, I think. That's what it means, probably. And the attacker can then increase the underlying amount by transferring derivative tokens to the derivative contracts. And then for subsequent users, the pre-deposit price will be heavily inflated and the calculation of the minimum mint amount will also be inflated. I understand. Here it's going back to the code. This is part of the stake. Initialize with a price of 1, but if you remove it, of course, total supply 0 is going to be most likely at the beginning before anyone stakes anything. So that's going to be, I understand now that that's for the first user. And it can be very inaccurate. In the worst case, it rounds down to 0 for users that deposit value that is less than the amount. Okay, I see. So if total supply is 0, it would add that. But then the user, let's say, can strike most of it, and there is a chance that it will not be 0 anymore, but then this part will end up being rounded to 0. So in the following POC, the attacker steals all the second user's deposit. The attacker first deposits 100 ETH and immediately removes all but one way. The attacker then transfers 10 WS ETH to the WST ETH contract. When the second user enters with 1.5 ETH, no additional safe ETH are minted since the minimum amount is rounded down to 0. Okay, I understand. So it's mainly that since it has removed almost all, then this would be rounded to 0. So what's happening is that it's not going to be increased because when there is some total supply, then this is going to change, right? And that apparently, it's used here, and it would be kind of changing the mint amount. So let's see, there is a POC here specified in hard hat, yes. I'm not going to read it all, guys. So yeah, it's just double checking. I guess it's verifying that that this is an issue. So should deploy the strategy contract, and then should deploy derivative contracts and add them to the strategy contract with equal weights. Okay, that's quite some POC there. Pretty long. Make sure to check it later, guys, if you want to get more details of it. It says tool use, VS Code hard hat, okay, and asymmetry mitigated. Use internal accounting to get the balance. I'm wondering, this is actually the mitigation confirm. I'm wondering if we can see the changes that they made. Maybe here. No, it's not available anymore apparently. Yeah. Usually, or in other places, I've seen that, like I was able to check the PR itself. So I was wondering if it would be the same here, but no. So we'll not use that. Okay, let's see. So that's the second high severity issue. Let's go ahead. It's a temporary issue shows in the staking functionality, which leads to the user receiving less minted tokens. Okay, a temporary issue shows in the staking functionality. Let's see what's it about. So in the derivative RETH prices, a quick explanation of the issue causing it. The problem is based on the function ETH per derivative. Okay, I remember that. That's the one that is not using the amount. If you guys remember, here it is. Oh, actually this one is using it, not the other then. Okay, let's see what else. As you can see, two statements can be triggered here. The first one, if pool can deposit, if pool can deposit amount, checks if the given amount plus the pool balance is greater than the maximum deposit pool size, and that the amount is greater than the minimum. What is that? Only this? And that the amount is greater than the minimum deposit in the pool. Second statement is meant to return a pool price. This one, which is slightly more than the regular one, because it's used in order to swap tokens in Uniswap, and therefore the price per token is overpriced. Let's see. Below you can see the regular price return in the first statement. Below you can see the pool price from the second statement, supposed to be used only when a swap is made. Difference between the regular price and the pool price. Let's see what is quick overview. What can result to users receiving less minted tokens? The first thing the staking function does is calculating the derivative underlying value. As true, this issue occurs on the RETH derivative. As we can see, the staking function calls ETH per derivative to get the price. Let's see that. What is it? The staking function, okay, but that's the staking function is here. And we are, using the ETH derivative to get the price. But takes as account the whole RETH balance of the derivative contract. Yes, here. For example, let's say the derivative RETH holds 200 elevated to 18. The pool has free space to 100 more till it reaches its maximum pool size. As the function calls ETH per derivative with the RETH balance of 200 instead of the amount being staked, the contract will think there is no more space in the pool, even though there is 100 more, and will return the pool price, which is overpriced, and meant to swap in Uniswap. Okay, let's move forward and see what is happening. So let's follow what actually happens. For now, we have wrong overpriced underlying value of the derivative RETH. Okay. Next, the function calculates the pre-deposit price. I will do the real calculation in the POC, but it's easy to assume that if the underlying value is overpriced, the pre-deposit price will be too based on the calculation below. Yeah. Let's say that the user deposits 5 elevated to 18. So here comes the real problem. So far, the function calculates the local variables after will be swapped to Uniswap. As mentioned, in the beginning, the pool has 100 free space. So in the deposit function, in RETH, the swap to Uniswap will be ignored as the pool can deposit will be true, and the message value will be deposited in the rocket pool. In the RETH, the pool can deposit was checking, where is it? It's returning true, and it was checking that the balance plus the amount is less than the maximum, and that the amount at the same time is bigger than the minimum. So again, as mentioned in the beginning, the pool has 100 free space, so in the deposit function, in RETH, the swap to Uniswap will be ignored as this is true. And the message value will be deposited in rocket pool. Okay, yeah, this part. This is true, so it will be ignored. And we'll go to the else. No, wait, if this is true, yeah, exactly. If it's true, it's ignored. And it would be executing that part. So next function calculates the derivative, receive ETH value. This time the function will return the normal price as there is space in the pool. Both derivative received ETH value and total stake value ETH will be calculated based on the normal price, which is this is operation. And this is adding to total stake. If we take the info so far and apply it on the mint amount calculation below, we know that the total stake value is calculated in the normal price and pre-deposit price is calculated on the overpriced pool price. So the user will actually receive less minted shares than he is supposed to get. The proof of concept, part 1, says we'll start from the start, okay, good. In order to get the right amounts of total supply and the RETH balance of derivatives, so I can show the issue result in POC part 2. The values below are only made for the example. Let's say we have two stakers, Bob and Kiki, each depositing 100. We have only one derivative, so we will have 100 weight. Bob deposits 100 as the first depositor and receives that much minted. So far, after Bob deposit, total supply is that, and the balance is that. What else? key deposits also that 100 as well, and receive those safe tokens. So far after Kiki's deposit, total supply is done. So from the first POC, we calculated the outcome of 200 stakes into Audit derivative. So both stake 100, and that's the different balances that I get. It is pretty different. So we get the total supply and the Audit balance the derivative holds. So we can move on to the main POC where I can show you the difference and how much less minted tokens the user gets. But it's a fact. Interesting. So I am going to show you how much minted tokens the user is supposed to get without applying the issue occurring. Without the issue occurring, a user deposits 5 by calling the staking function. The user receives that much minted tokens. Total supply is that. The balance is this of Audit. This time we apply the issue occurring, and as the first one, a user deposits 5 by calling the staking function. The user receives that much minted tokens. And the stats after the deposit with the issue, the difference between outcomes. Without the issue based on 5 deposit, the user receives this much, and with the issue occurring based on 5 deposit, the user receives less minted tokens. One more proof of concept. It's pretty long. I'm honestly not understanding it all, so I'm just going through it. So yeah, maybe you guys have better luck than me. But yeah, it's actually I would need to spend so much more time, so maybe you guys can do the same. Let's see what's proposed for mitigation. It says that the problem occurs with calculating the underlying value in the staking function. The function if per derivative is called with all the Audit balance, which should not be the case here. Therefore, the function calls bulk and deposit. Yeah, there is a lot there going on. I'd recommend creating a new function in the Audit derivative contract, which converts the message value to Audit tokens and using it instead of the whole Audit balance the derivative holds would be such a function proposed. Like this, we check if the message value converted into Audit tokens is below the maximum pool deposit size and greater than the minimum. Okay, that's the second high severity issue. Let's check now the third one, the third high issue. Users can fail to unstake and lose their deserved ETH because malfunctioning or untrusted derivative cannot be removed. Calling the following adjust weight in safe ETH contract can update the weight for an existing derivative to 0. Okay. However, there is no way to remove an existing derivative if the external contract that an existing derivative depends on or function or get hacked. This protocol's functionalities that need to loop through the existing derivatives can behave unexpectedly. Users can fail to unstake and lose their deserved as one of the severest consequences. Okay. This is the function. I'll just wait. Okay, so for example, calling the following onStake function would loop through all of the existing derivatives and call the corresponding derivatives withdraw function. When the WST-ETH contract is one of these derivatives, then the withdraw function would be called, which further calls the exchange. Okay, we've seen that. And if self is killed in the ST to ETH pool contract corresponding to Lido CRV pool becomes true, especially after such pool contract becomes compromised or hacked. And there are many things to take into account here, right guys? Calling such exchange function would always revert. Okay, this is expecting that something gets hacked. In this case, calling the unstake function reverts even though all other derivatives that are not the WST contract are still working fine. Because the unstake function is dust, user cannot unstake with and withdraw ETH that they are entitled to. That seems pretty important, definitely. This is the unstake function, and that's the withdraw from the WST. Okay, proof of concept. Those are the steps to follow. The WST contract is one of the existing derivatives. For this contract, the Okay, that's what we've mentioned. A list calls unstake function, but such function call reverts. Okay, yeah, no, it's basically reverting, and they cannot take their ETH back. Recommended mitigation steps. The contract can be updated to add a function, which would be only callable by the trusted admin, for removing an existing derivative that already malfunctions or is untrusted. Okay, not sure if we can now see that in PR with the changes. Not sure if this is it. No, not really. Okay. Or asymmetry mitigated, maybe this part. I'd like to see the PR, but no, I don't think I can. Probably, which is this one, 404, probably, yeah. Okay, so that's this one. Let's go to the fourth high severity. The price of SFRX ETH derivative is calculated incorrectly. So in the ETH per derivative, the calculated FRX amount is multiplied by 10 elevated 18 and divided by price oracle, but it must be multiplied by price. Oh, I've seen. It's always important to multiply, but it must be multiplied by. It's okay. It's wrongly set apparently. Multiply by price oracle and divided by that. Wow, quite a change. I'm wondering where could we learn that requirement if it was specified in the documentation. Not sure if we can use per derivative. No, I'm not sure how to check that. If you guys have any idea or if you do any further investigation, please write it in the comments. And yeah, let's find out. So the impact is severe as the function is used in stake, of course. One of the two main functions a user will interact with. The value returned by ETH per derivative affects the calculations of mint amount. Indeed, the incorrect calculation may over or understate the amount of safe ETH received by the user. The function is also used in withdraw function when calculating mint out. So incorrect calculation, well, yeah, definitely. If it's incorrect, then it's pretty bad, especially because it's used in stake and unstake. This is the actual operation, apparently. For example, we convert to asset and get that, but this function calculates the costs and divides it by the oracle. Okay, this is the expected, and this is what's actually reported that is happening. So it's showing what's the total Ethereum that it differs from that probably. Mitigation steps, change lines. Basically, yeah, fix that calculation, that operation. Okay, next issue, the fifth one here. Our ETH pool price calculation might overflow. Interesting. The RS derivative contract implements the pool price function to get the spot price of the derivative asset using a Uniswap V3 pool. The function queries the pool to fetch this parameter from the swap and does the following calculation in the function. Okay. The main issue here is that the multiplications in the expression, so this may eventually overflow. Okay. This case is taken into consideration by the implementation of the Oracle library getQuotaTick function, which is part of Uniswap v3 periphery set of contracts. Okay. Note that this implementation guards against different numerical issues, in particular, if in line 58 checks for a potential overflow. So recommendation would be the pool price function can delegate the calculation directly to the getQuotaTick function. Let's see how or where we would add it. It's instead of okay. It would be instead of returning it like that, then we would be doing it instead through that. It's passing the parameters, basically, and it has that check. Okay, that's good.
All right, so let's continue with the high issue number 6. WST ETH derivative assumes that almost 1 equals 1 peg of ST ETH to ETH. Okay, lots of people found this issue. The WST ETH contract implements the ETH derivative for the Lido protocol. The staked ETH token is the liquid representation of the ETH staked in this protocol. There are two different places in the codebase that indicate that the implementation is assuming a peg of 1 ETH is almost equal to 1 staked ETH, each with different consequences. Even though both tokens have a tendency to keep the peg, this hasn't been always the case, as it can be seen in this chart or this dashboard in Dune. And there have been many episodes of market volatility that affected the price of a staked ETH, notably the one in June. It was around 0.93. Okay. The first indication of such an assumption is the implementation of ETH per derivative. This function is intended to work as an estimation of the current value in ETH of 1 unit. That's true. We got it there. Okay. In this implementation, the function simply queries the amount of staked ETH for 1 unit, the WST ETH, and returns that value, which clearly indicates a conversion of 1 staked ETH for 1 ETH. The other indication and most critical one is in the withdraw function. This function is used by the SafeETH contract to unstake user positions and rebalance weights. In the implementation for the WST-ETH derivative, the function will unwrap the WST-ETH for the staked ETH and use the curve pool to exchange the staked ETH for ETH. See how it's okay. Yeah, that's where we were checking that there was a lot of different logic that we would mention that we would in a complete audit we would just go back and double check, right, and dive deeper on that. So of course there was an issue. So this issue is the calculation of the minimum out variable. So this one, okay, maybe this that is sent to the curve exchange function here. What is it? To validate the output amount of the trade. As we can see in the line 60, the calculation is simply applying the slippage percentage of staked balance. This means that, for example, given the default slippage value of 1% trading 1 staked ETH will succeed only if the rate is above 0.99. Okay, that's pretty high. Larger amounts will be more concerning as the curve of automated market maker implements non-linear invariance. The price impact will be bigger. The rebalance two-way function withdraws all the balance before rebalancing, which means it will try to swap all the staked ETH held by the contract. Okay, it shows here the mitigation. This could be mitigated by adjusting the max slippage variable to allow for lower exchange rates. However, this would imply additional issues. First, the setMax slippage is an admin function that needs to be manually updated with extreme care. In times of high volatility, the owners won't be able to update this variable as frequently as needed to keep up with the exchange rate. This means that users that want to exit their position won't be able to do so since the exchange for the derivative will fail. Second, on the contrary, if the owners decide to set a higher slippage value by default to allow for unexpected market conditions, withdrawals and rebalancing, in particular, will be victim of sandwich attacks by MEV bots. Okay, here let's share the proof of concept, adding a foundry test. The following test replicates the market conditions during last June where staked ETH was trading at 0.93. Needs to be forked, blah, blah. Here the user wants to exit their position, but the call to unstake will revert since the exchange in the curve pool will fail as the output amount will be less than the expected minimum. Note the snippet shows only the relevant code for the test. Maybe you can take a quick look. We're adding a derivative, depositing 1 ether, and we're staking that 1 ether, and user shares is the balance of that user in SafeETH, and it expects to revert with the unstaking of the user shares. Okay. And the recommendation. Let's see how to mitigate it. The user should be able to decide on the slippage and set the expected minimum output amount to correctly handle different market conditions and user expectations. Okay, that tells us that when we see some separate function for setting the max slippage and that it's only even more if it's only owner, we could remember this issue and make sure to remember that that okay there is some risk there. Okay, so similar to how decentralized exchanges work, the user experience can be improved by using a front end that queries current exchange rates and offers the user a preview of the estimated output amount. The ETH per derivative function should also take into account the results of swapping the staked ETH for ETH using the curve pool, similar to how the SFRX derivative implementation works. Okay, so that's this bug. Good. Let's go now to the seventh high severity issue. All withdrawals are unreliable and depend on excess rocket deposit pool balance, which can break the whole protocol. The Asymmetry Protocol promises that a user can call safe on stake at all times. What I mean by that is that the user should be able at all times to burn these safe tokens and receive ETH in return. This requires that the derivatives held by the protocol can at all times be withdrawn, converted to ETH. Also, the rebalance two-ways functionality requires that the derivatives can be withdrawn at all times. If a derivative cannot be withdrawn, then the rebalance two-ways function cannot be executed, which means that the protocol cannot be adjusted to use different derivatives. For the WST ETH and SFRX ETH derivatives, this is achieved by swapping the derivative in a curve pool for ETH. The liquidity in the respective curve pool ensures that withdrawals can be processed at all times. The RS derivative works differently though. Okay, yeah, I think it was mentioned in the previous issue, but it's a bit different, yeah. Withdrawals are made by calling rocket token RS burn function. Okay, this is the code in withdraw. Withdrawals are made by calling. Yeah, okay, I remember. Okay, I remember there was something weird here. The issue with this is that the rocket token RF burn function only allows for excess balance to be withdrawn. Example, if that has been deposited by stakers but that is not yet staked on the Ethereum Beacon chain, so Rocket Pool allows users to burn ETH and withdraw ETH as long as the excess balance is sufficient. The issue is obvious now. If there is no excess balance because enough users burn ETH or the mini pool capacity increases, the Asymmetry Protocol is basically unable to operate. Withdrawals are then impossible, which breaks unstake, SafeETH unstake, and SafeETH rebalance to weights because it's depending on something else. That's the thing. That's a kind of denial of service here. When you depend on another function, wondering if that's because if there's nothing to burn, then this can revert maybe. Or let's read further. I show in this section how the current withdrawal flow in RETH derivative is dependent on there being excess balance in the rocket deposit pool. The current withdrawal flows calls the rocket token RETH burn function which executes this code. It's probably from internally from this contract. There are some verifications that this executes withdraw deposit collateral. Withdraw ETH from deposit pool if required. And that inside this then calls withdraw excess balance, this one, to get the ETH from the excess balance. It's subtracting ETH balance to the ETH required. Okay, showing the internal implementation. And this function reverts if the excess, oh, that's right. It reverts if the excess balance is insufficient. So what we want to burn is not, it doesn't exist, it's not enough. Which you can see in the require here, amount get less or equal. Otherwise, insufficient excess balance for withdrawal. Recommended mitigation steps. The solution for this issue is to have an alternative withdrawal mechanism in case the excess balance in the Rocket deposit pool is insufficient to handle the withdrawal. The alternative withdrawal mechanism is to sell the RF tokens via Uniswap pool. You can use the Rocket deposit pool get excess balance to check if there is sufficient excess ETH to withdraw from Rocket pool or if the withdrawal must be made via Uniswap. The pseudo code of the new withdraw flow looks like this. This is the proposal. If Rocket pool access, pseudo code, okay. Exist balance is sufficient, then burn. So it's adding the condition. Otherwise, swap RETH for ETH via Uniswap pool. I also wrote a code for the changes that I suggested. Okay, as a condition, can withdraw from Rocket pool. Probably another function, yeah. Returning boolean is now with a condition here that get excess balance is major or equal than ETH amount, and else use Uniswap. So we are using the swap exact input single hop from Uniswap, and we're providing the minimum amount as well. I mean here, yeah. Okay, good to learn this. Interesting to keep in mind. Well, at least when I will see this contract and the excess balance, I will be able to maybe come back to this bug and verify if it's anything similar. Alright, let's go for the last high, the eighth one. Staking, unstaking, and rebalance to wait can be sandwiched. A lot of people found this and raised it. Not bad. Let's find out what it's about. Our ETH derivative can be bought through Uniswap if the deposit contract is not open. While a max slippage variable is set, the price of our ETH on Uniswap is the spot price and is only determined during the transaction opening sandwich opportunity for MEF researchers, as long as the slippage stays below max slippage. This is also true for WST ETH on withdraw and FRX ETH on deposit and withdraw. That goes through a curve pool when unstaking for FRX ETH, while the curve pool has much more liquidity and the assumed price has one-on-one ratio for WST ETH and FRX ETH seem to be using a swap price before applying the slippage. These attacks are less likely to happen, so I will only describe RETH one. The proof of concept, while the current RETH derivative contract uses Uniswap v3 0.05% pool, I'll be using the Uniswap v2 formula. Okay, to make this example simpler. In both cases, sandwiching is possible. Default slippage is set to 1% on RETH contract at deployment. On RETH, on deployment, on the initiate, yeah. Let's take a pool of 10,000 RETH for 10,695 ETH. Same ratio is on the Uniswap v3. User wants to stake 100 ETH, a third of it will be staked into RETH according to a one-third weight for each derivative. So bundle, transaction 1, researcher swaps 100 ETH in for 9263 RETH. New pool balance is not much. Okay, after this. And 10,795 transaction 2. User stake his ETH. The Rocket Pool deposit contract is closed, so the deposit function takes the current spot price of the pool and applies 1% slippage to it to get minimum out. Current ratio is 0.9177. ETH to swap for RE 33,333. So minimum amount that is 30,284 RE. Seems lower than this. Contract swap 33,333 for 30,498 RE. is a slippage of 0.061, so below 1%, and received more than minimum out. New pool balance is that transaction 3. Researchers swap back the 9263 ETH for around 160.61 ETH. New pool balance that researcher made 0.61 ETH to of profit. Could be more as we only applied a 0.61 slippage, but we can go as far as 1% in the current audit contract. Uniswap V3 pool would or could even worse could be even worse as researcher with a lot of liquidity could be able to drain one side. Liquidity is very concentrated. Add liquidity in a tight range, execute the stake, and then remove liquidity and swap back. Yeah, okay. I remember reading somewhere that that's like when you depend on a third party for some operations or for some, well, yeah, any kind of logic, it's worth to look very, very closely because yeah, it can you don't know what's on the other side. So the recommended mitigation steps, the audit price should be determined using swap price and users should be able to input minimum out in the stake and rebalance to wait function. Interesting. Okay, so that means okay because it's max slippage. It's okay. It's hard coded. So that will help me investigate further when I will see somewhere else that the maximum slippage it's set by the owner. I will remember that there might be an issue there, depending of course on the features. But yeah. Okay, so that's all the highs. Let's take a quick look now to the medium risk findings. Division before multiplication, truncate, minimum out, and incurs heavy precision loss. Results in insufficient slippage protection. Let's see what it is. So when calculating the minimum before doing trade, division before multiplication. Where is that? Inset max slippage. Safe is line 206. Will not be the same for me, but let's see. Where is it? Maybe I will open it here. Line 206, and that's multiplication, which calls the corresponding derivative contract. Case 1, which is calling, okay, here it is. That operation is multiplying for that and then dividing. As we can see, the division before multiplication happens in the line of code minimum out is this one. It's dividing by that before multiplying. If max slippage is 1017, then that operation is done, and then the division. Okay. Then minimum out is 0. Slippage control is disabled because of the division before multiplication. Okay, here it was a bit more hidden, I must say. But yeah, it does make sense, actually. This is in between parentheses. That's why this will be done, this division before multiplying. Okay, case 2, the division before multiplications happens below. Same case, actually here, because it's wrapped in parentheses. Okay, nice one. Let's go to the second medium. In SFRX ETH might revert on redeeming non-zero amount. Okay, non-zero. Interesting. Okay. When unstaking the withdraw of its derivative is called withdraw calls redeem. This function might revert if the amount is low due to the following line redeem, where amount is shares. It requires assets to to be different than zero. Where preview redeem returns convert to assets, which is the shares scaled by the division of total assets by total supply. So if amount equals 1 and total assets in SFRX is less than its total supply, then that's equal to 0 and redeem will revert. This revert is in withdraw. This reverting withdraw causes a revert on stake. Okay, which means the funds cannot be unstaked. Amount may be as low as 1 when the weight for this derivative has been set to 0
and funds have adjusted over time through staking and unstaking until only one remains in the SFRX ETH derivative. Instead of just being depleted, it might thus block unstaking. It's interesting to see it as a medium, as it's a kind of block, but okay, probably was discussed. So recommended mitigation in withdraw, check if this amount is equal to zero and simply return if that's the case. Okay, it's an extreme case. So disagreeing with the severity, yeah. So probably it was raised as a high, but then it was changed to apparently even too low. But apparently after some discussions it was brought back to medium. Good. Let's go on. Let's go to the third medium. Potential stake, denial of service if sole security holder at the first depositor and stakes total supply minus one or total supply one. Total potential inability to stake if sole security. Okay. Proof of concept. The goal of this POC is to prove that this line can revert from underflow, I understand. Or no, wait, what's that? Let's see, this can occur if the attacker can cause that the pre-deposit price is zero. Okay, then division by zero. Okay. A user who is the first taker will be the sole holder of 100%. Okay, this is similar to the one of the high issues that we've seen here. A user who is the first taker will be sole, yeah. They can then unstake and therefore burn total supply minus one, leaving a total of one way of safe ETH in circulation. That's exactly the same POC that someone proposed for a high. Okay. With total one, we see that the above code block will execute else code path, and if the underlying value equals zero, then pre-deposit equals zero. So this is a different issue here. Underline is set in early lines. For a simple case, assume there is one derivative with 100% weight. Let's use RE for this example, since the derivative can get its ETH per derivative price from an AMM. In this case, assume the ETH per derivative value has been one derivative ETH is worth less than one ETH. In this case, also assume that since there is one way of safe ETH circulating, there should be one way of ETH taken through the protocol. This case will result in adding to underline this match, which is probably rounded to zero. We can see that it is therefore possible to cause a divide by zero revert. Yeah, that's another issue of, okay. Recommended mitigation steps, assuming the deployment process will set up at least one derivative with a weight. Simply adding a stake operation of 0.5 ETH as the first depositor as part of the deployment process avoids the case where safe ETH total supply drops to one way. Otherwise, within on-stake, it is also possible to require that total supply does not fall between zero and minimum supply, where minimum supply is, for example, the configured minimum amount. Apparently, it was also raised as a high and reduced to medium. Let's go on. Okay, lack of deadline for Uniswap AMM. Deadline, okay, it's missed. It's missed here. So basically, yeah, impact, because front running is a key aspect, then we really need to we need to be aware of all the parameters here. Yes, okay. Because front running is key aspect of AMM design, deadline is a useful tool to ensure that your transaction cannot be saved for later. It's usually set to block timestamp, the, the deadline. Due to removal of the check, it may be more profitable for a validator to deny the transaction from being added until the transaction incurs to the maximum amount of slippage. Recommended slippage steps. The deposit function should accept a user input deadline that should be passed along SAP. Okay, either that or nice. Next one, missing derivative limit and deposit availability checks will revert the whole stake function. The users will not be able to stake their funds and there will be loss of reputation. The safest contract stake function is the main entry point to add liquid ETH to the derivatives. Accordingly, the stake function takes the user's ETH and converts it into various derivatives based on their weight and mint an amount of safe ETH that represents a percentage of the total assets in the system. The execution to deposit the available derivative is done through iterating the derivatives mapping in safe ETH storage contract, the derivative account. And for all the derivatives, the stake function calls the derivative contract deposit function. The DeFi Protocol implements a daily staking limit both for staked ETH and wrap staked ETH as per their docs. Accordingly, the daily rate is 150,000 ETH and deposit function will revert if the limit is hit. However, this check was not done either stake or deposit. So if the function reverts, the stake function will all revert and it will not be possible to deposit to the other derivatives as well. Okay, here it's okay. Another issue lies in the Audit contract having the same root cause below, missing validation and external transaction dependency. For all the derivatives, the stake function calls derivative contract deposit function below the Audit deposit. In the line 160, it checks the pool's availability to deposit with pool can deposit. However, as per Rocket Pool's contract, there is another check to confirm the availability of the intended deposit. The deposit function doesn't check this requirement whether the deposits are disabled. As a result, stake function will all revert and it will not be possible to deposit to the other derivatives as well. Recommended mitigation steps for the wrap stake ETH contract: checking the daily limit. It's major than the amount to stake. It's bigger. The Audit contract: checking the Rocket's pool deposit availability, and wrap the stake functions iteration inside Trycash block to make the transaction success until it reverts. Again, was raised as high, but reduced to medium. Let's continue now with the DOS attack due to external core failure. Impact: stake or unstake and rebalance to weights. If any one of the derivatives fail to deposit or withdraw, the whole function will revert, causing DOS, denial of service. The impacts include users' funds would be locked for a period and contracts become inoperable until the external code resumes. Proof of concept: in stake, each derivative iteration, ETH per derivative and deposit, will be called. Yes, okay. In unstake, each derivative is iterated to withdraw. Yes. In rebalance to weight, each derivative is iterated to withdraw and then deposit. Yeah, those 4 loops. For each of the current derivatives, there are several different scenarios where the ETH per derivative deposit or withdraw could fail. In the SFRX ETH contract, redeem could fail due to not enough allowance. Exactly. Yeah, I remember noticing that. I don't know if I did write about it in safe ETH withdraw. What is? I'm wondering because it's in the withdraw function. I'm going through too. Anyways, it's inside. Yeah, doesn't matter. But yeah, redeem derivative. SFRX. Okay. Withdraw. Yeah, because you know what? It's not checked. There's no verification of that amount. We just redeem it, right? That makes sense, definitely. In the contract code, exactly. That's redeem. And then in FRX, it's exchange and could fail due to mean out requirement. Okay, not sure now where it came from. Then deposit could fail because of submit and deposit, or submit can be paused. Below is the FRX ETH minter contract. That's an external one, I understand, or something else from the protocol. If submit pause is turned on, this deposit function will revert. Submit pause. Yeah. In RETH sol contract, the reth address and get address is called in multiple places, but it could return wrong address or address 0, and it's not verified, I guess. Since the refer address could return an unexpected result, can be reset or deleted, then the whole function call will revert. In the Rocket storage contract, we have those: get address, set address, delete address, and read address is referred in So used in those places, those functions. Oh my god, this long, lots of places, and yet it's a medium. Get address will also influence bulk and deposit, so it's used in many places and in the burn as well. There is no guarantee that the function burn will succeed. It's about the address, right? Because in Audit contract code below, the execution may fail in several cases. Get total collateral, get contract address may fail due to the same reason above. The require could fail due to low balance, burn, message sender transfer could fail due to not enough gas. Okay, interesting. At the end, okay, not enough gas. And in WST ethsol, function exchange could fail due to minor requirement. As long as any one of the above could fail, the whole stake and stake or rebalance will revert, and user's fund would be locked until external dependency is resolved. The contract will lose the core functionality. Definitely denial of service. Recommended mitigation. Use strike ice to skip the failed function call. Then the contract will be more robust to unexpected situations. In case of deposit, redistribute the fund into the other derivatives according to the weights might be an option, since rebalance will be done regularly. For withdraw, maybe temporarily record the missed amount and give the user opportunity to retrieve later. Okay, let's go to the next medium. In the PEG scenario, forcing full exit from every derivative and immediately re-entering can cause big losses for depositors. There are three sources of losses in this scenario. Protocol currently doesn't localize exit and force exits all positions. Protocol immediately tries to re-enter the position based on new weight. Protocol is inefficiently exiting and re-entering the positions. Proof of concept assume positions are split in following ratio value: 10, 70, and 20. Now frag starts to the PEG forcing protocol to exit frags ETH and rebalance to say 80%. Okay, I'm going to move forward because I'm not sure what it's been done here, to be fair. Forcing full exit from every derivative. That one I'm not sure I understand. So guys, well, again, if you want to add here in the comments, please do. We can try to understand it together. It seems it had some comments during mitigation. Let's continue another possible DOS attack on stake. Rocket Pool RE tokens have a deposit delay that prevents end user who has recently deposited to transfer or burn tokens. In the past, this delay was set to 5,760 blocks mined, approx 19 hours. This delay can prevent Asymmetry Protocol users from unstaking if another user staked recently. Okay, this is delay. So while it's not currently possible due to Rocket Pool's configuration, any future changes made to this delay by the admins could potentially lead to a denial of service attack on the unstake mechanism. Currently, the delay is set to 0, but where deposit delay is probably from the outside contract before token transfer from address uint. So proof of concept. Specifically, protocol users taking actions could prevent other users from unstaking for a few hours. A malicious actor can also exploit this to be able to block all unstake calls. If Bob manages to repeatedly stakes the minimum amount every 19 hours, all future calls to unstake will revert. So Bob needs to repeatedly stake the minimum amount. Eventually, all calls will revert. Recommended mitigation: consider modifying RETH derivative to obtain RETH only through the Uniswap V3 pool. On average, users will get less RETH due to the slippage, but will avoid any future issues with the deposit delay mechanism. Okay, pretty specific issue there. I'll move on. 10. Stack Ether when use function stake with empty derivatives when derivative count equal to 0. After initialize the contract of ETH, if someone call stake before add derivative, the function stake skip the 2 for seconds because the derivative count is equal to 0. That makes sense. and don't deposit in the derivative contract also means 0 tokens to the sender. Finally, the amount of message value will stack in the contract. That's a good one. So we need a verification there. One stake, the derivative count should be greater than 0. So this one. Nice. Okay. I think that's it for this one. Next medium will be residual ETH unreachable and unutilized in safe ETH. Unreachable, ETH unreachable, and unutilized. Unlike the other three contracts in scope, safe ETH does not have a measure in place to utilize the residual ETH, be it accidentally received, 0 ETH output from unstaked, ETH sent in via stake fails to deposit into a derivative due to uninitialized derivatives and weight, as I have explained in a separate submission. Interesting. In the derivative contracts, the above issue is wiped clean via address this balance every time withdraw is predominantly invoked in unstake of safe ETH. But it seems it's not on in safe ETH, apparently. As in safe ETH amount before and ETH amount after are used to determine the amount to withdraw, or the rebalance, respectively, in unstake and rebalance. Mitigation steps recommended: consider having rebalance to weights refactored as follows. So it's adding instead of calculating it like that, just to take the balance at this stage. Well, that's fair. That's definitely going to show the balance. Okay, yeah, definitely. So it's interesting to find this in the code, right? To just see that this is done, but to get to the point where you notice that it can be a problem and that it's just, yeah, a good suggestion, definitely. All right. And the last medium, no slippage protection on stake in safe ETH contract. Mint amount is determined both by total stake value ETH and pre-deposit price, while the former is associated with external interactions beyond user's control. The latter should be linked to a slippage control to incentivize more staker participations. Proof of concept, as can be seen from the code block below, ETH per derivative. My God, that has had so many issues in this audit. ETH per derivative serves to get the price of each derivative in terms of ETH, although it is presumed the prices entailed would be closely, stably pegged one-on-one. No one could guarantee that the degree of volatility, just as what has recently happened with the USDC peg. So there was similar issue before about that one-on-one that cannot be guaranteed. When underlying is less than total supply, pre-deposit price will be smaller and inversely make mint amount bigger. And if mint amount is bigger, any slight change in price movement in the same direction can consistently cumulative, and reflective in stake calculations. This can make two stakers calling stake with the same ETH amount means a pair getting minted different amount of stake ERC20 tokens. And to mitigate it, consider having a user inputable minimum mint amount out added in the function parameters of stake. Okay, so it's about adding a condition. So taking into consideration next time I see a stake to see how it's the minimum mint amount. The good thing is by recording this video, then I have this knowledge that I've seen this before, and I will just be able to come back to the specific issues. That's fantastic. Okay, so all mediums are done, guys. I will not go through all the low risk now. Let me know in case you feel like it's worth it to go also through the low and non-critical. I might be doing a separate thing for that if so. So let me know what you think about the way I have gone through the high risk findings and about the medium risk findings. I'm definitely expecting you guys to tell me what is boring, what doesn't work, what is good, what to follow, continue doing, and if it is actually working for you. If you would expect maybe that we could do this kind of together in a live session by any chance. I mean, I'm open for that. I just would like to hear some feedback. I am enjoying this. I'm actually taking out of good things from these videos. So because I'm definitely learning, I have to read all that. There are obviously some that I can't totally follow or understand, but I guess together we will get to that. And yeah, I have other plans for low risk and non-critical issues to make separate videos. And same for cache optimization. So mainly I will leave it on those. So anyways, we had a lot of them. So thanks guys for staying around. Please subscribe. I'm planning a lot of these kind of similar videos for shadow audits. I appreciate any kind of support. So if you guys can just like and subscribe, share these videos if you find them useful in your Twitter account or in any Discord channel that you're into. So that would be extremely helpful for me to see that this is actually that it's actually worth it for you guys and that you can make some use of it. So yeah, I think we completed all that was planned with the scope of asymmetry audit that we went through the documentation, we did the code overview, and we have finished the code report. So thanks guys for staying until the end if you did, and take care and see you next time. Bye.